All righty. So let's go share screen. Cardiovascular 3. So this cardio 3. Um, so let's run through this. Shouldn't take too long. So arteries versus veins. So basically these are pipes that carry blood throughout the body. Arteries carry blood away from the heart. We're not talking about arteries on the heart itself, and then veins carry blood to the heart. Don't worry about if it's got oxygen or not in it. So most arteries are oxygenated, but there are exceptions, because think about the pulmonary artery or the pulmonary trunk that goes into the pulmonary arteries. That those are deoxygenated because they're going to the lungs to get oxygenated. Then you have pulmonary veins that are going back to the left atrium, and those are full of oxygen. So there are exceptions. Generally, arteries are oxygenated, veins are deoxygenated, but there are exceptions. So vein can carry blood to the atria of the heart, or veins do. Generally, it's deoxygenated, except for then you have pulmonary veins, like we were talking about, and those are full of oxygen. Okay, so the heart's gone here, but you can see the aorta. That's, of course, carrying oxygenated blood. And you got these three major branches off of it. Remember the brachiocephalic trunk that splits into the right common carotid, and you can't see it here, but the right subclavian. Then you have the left common carotid and the left subclavian branching off that. And then you go down the descending aorta here. Oh, that's oxygenated. Then that's going to split into the common iliacs. And there's branches off of this that we'll talk about in a little bit. Circuits of the vascular system. You got the pulmonary circuit. So we're just keeping it simple, from the heart to the lungs and back. That's the pulmonary circuit. And then the systemic circuit is from the heart to the body and back. So the right ventricle is pumping to the lungs, and the left ventricle is pumping to the body in general. Don't forget your three layers: tunica interna, tunica media, and tunica externa. That's just layers of the vessels. So like here's an artery. You can tell it's an artery because it's kind of ruffled on the inside. That's because of these elastic fibers, right? And an artery is going to look nice and round usually, and it's going to have a real thick, smooth muscle layer here, which is the tunica media. And then you're going to have connective tissue on the outside, which is tunica externa. The vein's going to have the same three layers: tunica interna, right? It's mainly the simple squamous and a little bit of connective tissue under it. Then you got the smooth muscle, which is tunica media, and then you have the tunica externa, which is the connective tissue on the outside. Notice the smooth muscle is not nearly as thick in the veins. And also the tunica interna is not ruffled. It's generally smooth. You just have less elastic fibers over here. Conducting arteries, the elastic arteries are the big guys, that are close to the heart. So they have a lot of elastic fibers in them. The tunica media has, it's still got smooth muscle in it, but it's got a lot of elastic fibers. So like the pulmonary artery, the aorta, those are examples of elastic arteries. Where you get on down further, say the radial artery or the ulnar artery or the tibial, they call those muscular arteries. So they have a relatively small diameter, but they have a thicker tunica media. And so that's got a lot of smooth muscle fibers, and this can undergo diameter changes due to the autonomic nervous system. So your autonomic nervous system has, a lot of control over these muscular arteries as far as if they're going to be dilated or constricted. Arterioles, I'm not going to ask you how many microns across they are, but they're fairly small. Here it says 30 microns. I guess that's about right. Poorly defined tunica externa, incomplete tunica media. In other words, you do have smooth muscle, but it's kind of scattered. around, but you still have smooth muscle. So they control blood from between the arteries to the capillaries. Capillaries spelled wrong down here, by the way. So one arteriole can lead to lots of capillaries. So true or false? Do capillaries have smooth muscle around them? False, because capillaries, smooth muscle would just be in the way. They're for exchange mechanisms. So for, like oxygen and CO2 and nutrients and waste and stuff like that have to get either across or back, uh, to or from the tissues. Across the epithelium of the capillary. So a bunch of smooth muscle around the capillary would be in the way. So another way to ask that question would be, are capillaries under autonomic control? And that would be really no, because they don't have smooth muscle around them. Okay. So how can you move blood? Say you have blood in your feet and you're trying to get it back to your heart in the veins. What's going to help you do that other than the pressure differential? You're always flowing from a high pressure to a low. Well, what about one-way valves? So those can be found in, a lot of them are in the limbs. And so they call them semilunar type valves. That's why they're trying to get rid of that semilunar designation in the heart. They're just trying to call them pulmonary valve and aortic valve. I don't stress on that. So they're one-way valves that don't allow backflow, hopefully, and it helps move the bolus of blood up section by section. And it's just kind of folding of the tunica interna on the inside. Skeletal muscle pump, this will make more sense if you can see it. So, by the way, there's a one-way valve, there's a one-way valve. So now when you walk, this muscle is going to squeeze on this vessel, and of course the blood up here is going to go up, and it's going to go through the valve, no problem, because it's going to be open, letting it go. But it can't go back down because the one-way valve is stopping it. So when you walk or use muscles in other areas, they can squeeze on veins and help, push that blood towards the heart. Then there's also thoracoabdominal pump. So breathing changes the pressure within thoracic and abdominal cavities. And so it kind of creates a push-pull through there. And in these larger vessels of the anterior cavity, that helps move the blood towards the heart. So if I said on a test, name 3 things that help blood get back to the heart from the veins in the, say, the feet or whatever, you would go, one-way valves, skeletal muscle pump, and thoracoabdominal pump. I'd be able to describe it in like one little concise sentence for each. Now, do lymphatics, which is our last lecture, on the lymphatic vessels, do you have these same mechanisms in effect? Yes, they have valves. The big ones do. They have skeletal muscle pump works on them, and the thoracoabdominal pump does too. In addition, valves have one extra thing. The lymphatics have an extra thing. The great big lymphatic vessels can contract on their own, and so that also pushes blood towards the heart. Okay. So the venules collect blood from the capillaries. I'm not going to ask you size. This is wrong, by the way. Let's just say microns, not millimeters. Millimeters, not microns. You got medium-sized veins and large veins. And this just contrasting arteries versus the veins. If you notice, the arteries are usually round because they have some nice, thick, smooth muscle around them, where veins can kind of collapse. They're kind of flattened. For the tunica interna, remember, it's kind of rippled or ruffled inside of arteries, and it's smooth inside of veins. You have more elastic fibers, so you got an internal elastic membrane on the arteries. You don't have one on the veins. Tunica media is thick on the arteries, thinner on the veins. I didn't even point at it, but external elastic membrane on the arteries, not on the veins. And then you know, you got a lot of elastic fibers and collagen fibers. You got some of that in the veins, but not nearly as much in the elastic department. We talked about the closed system, so the red blood cells stay inside the vessels, even the capillaries. Just the fluid can go out. So the plasma, if it leaks out, it becomes interstitial fluid. And then the interstitial fluid can go back into the capillaries and be plasma again, or it can go into the lymphatic system where it's then called lymph. And we'll talk about that more on the last lecture. So capillaries are small, you know, maybe, I don't know, 10 microns. They can even be smaller than that, I think. So the red blood cells, which are around 8 microns, and they can kind of fold up and get through if it's a little bit tight in there. They pretty much line up single file to go through capillaries. But they're kind of, like I said, those red blood cells are kind of flexible. Most capillaries are arranged in the capillary bed, and that thinness allows for the exchange of material between the blood and the tissues. So that's what I was talking about. There's no smooth muscle in the way. So see, no smooth muscle. Now you can have a little precapillary sphincters. I'm not counting that. But look at the way the arteriole has smooth muscle around it. So yeah, you can shut down what goes to the capillary bed and then go around it. You know, your autonomic nervous system can figure out where stuff needs to go. And a lot of times, you know, in cold or hot, you know, certain capillary beds will be either shut down or opened up due to temperature also. Okay. Let's see. Here's an alveolus that's going to have simple squamous on the inside. Here's a capillary that's going to have simple squamous on the inside. And remember, all epithelia is connected to a basement membrane. Well, this is kind of weird because these two share a basement membrane instead of having a separate basement membrane for each, because that would be too much stuff. The O2 and the CO2 wouldn't be able to get across two basement membranes, so they only have one. They share it. So I can go true or false. Alveoli and capillaries share a basement membrane. You'd go true. And for this test, I'm just giving you one type, and it's a continuous capillary bed. That's your normal one. Most capillary beds are these. They're leaky, but they're not that leaky. These are just your normal capillaries. It's called a continuous capillary bed. You know, diffusion mainly is what, let's go back. You know, stuff can diffuse out, but the red blood cells stay in. Can stuff be transported across a capillary? Yeah, but we're not getting into that. That's physiology. Don't worry about fenestrated capillaries. These are in the kidneys. They're even leakier. See the little holes? Don't worry about it till next test. Same thing, sinusoidal. Don't worry about those till next test. They're really leaky. And so these are in the liver and the spleen. But this is just what regular old capillaries look like. Pretty cool. That's a nice electron microscope picture. That, you're not seeing capillaries, they're too little, but you're just seeing a bunch of arteries and possibly arterioles. But yeah, if you threw the capillaries in here, it would just look solid red almost, but probably they can't inject that plastic in something that small. So movement across the capillary mainly is diffusion. Don't worry about the endo and exocytosis. You'll get that in physiology. This is showing its closed system. Capillary spelled wrong there. Don't spell it like that. And this is just showing you where the blood is in your body at any given, you know, snapshot in time. Most of it's on the venous side. This kind of interesting. The heart can hold up to 7%. Probably even more than that if you're like a long distance athlete. Okay. Don't stress on this other than the fact that arteriosclerosis, generic word, means hardening of the vessels. Atherosclerosis it's the process, so the depositing of the lipids and other stuff that basically becomes this plaque, and that results in hardening and narrowing of the vessel. So arteriosclerosis is just hardening, where atherosclerosis is more like the process that then leads to hardening, if that makes sense. They sound very similar, so be careful. Just spell them right. That's what an artery is supposed to look like. Look how beautiful. Right? And there's my tunica interna, tunica media, tunica externa. Here's a similar vessel. It's probably this side of a heart. This is a coronary vessel. This is a bad one. So that's all that's left of the lumen right there. This is that huge plaque that's built up under it. So this is advanced atherosclerosis. The only blood is coming here. So you can see how something like that could break loose and become unstable. So you have a vulnerable plaque here. The platelets could, say if that gets kind of broken through, the platelets could stick on top of here, and then the platelets themselves can get dislodged and go downstream and cause a problem. Or even this plaque itself could dislodge and go downstream and block something up. And so this a coronary vessel that has a little bit of this going on, maybe, 50, 60%. They could treat this with medications, or they could put a stent in here and open that back up. Or if it gets really bad, they can take a vessel like a little vein and they can bypass over the obstruction. And that's called a coronary bypass. So you probably heard of people getting single, double, and triple bypasses. That's what they're talking about. And that'll reestablish blood flow down. You can see how things get smaller and smaller. So if a plaque were to break loose, it would probably stop up somewhere down here, and it could shut off the blood flow for everything downstream. And so that could basically, that's a heart attack. Myocardial infarction. An aneurysm is kind of the opposite problem. So instead of a clog, it's a weakness in an artery. In this case, this is an aorta, which is the biggest artery you got, and look how it's bulged out. So that could burst. So that's a dangerous situation. They actually have ways of repairing this. They can wrap things around this. My first cadaver I ever worked on had a wrap around his aorta, and apparently it was successful because he did not die of that. It was all healed pretty much around here. There's also sleeves that they can put inside of here if it's in a certain place, and it takes the pressure off these walls. Okay. That's your iliacs, by the way, your common iliacs, and then they're going to divide into your internal and your external iliacs. So once you get below the diaphragm, there's some branches off of the aorta, right? So you got the celiac trunk, and you can see some of this here. Probably your celiac trunk is up in here. It's kind of indistinct here. But the celiac trunk branches into 3 vessels. One goes to your stomach, one goes to your liver, one goes to your spleen. But it's a little chunk that comes off the anterior of your aorta, right? And below that's the superior mesenteric. Courses through the mesenteries go into your intestines, upper part of your intestines. The renals, of course, go to the kidneys, or one on each side. Gonadals going to either go to testes or ovaries, right? Inferior mesenteric is going through the lower part of the intestines and feeding those, and then the common iliacs we talked about. There's a little mnemonic. I changed it up. Just go, can small mice really get in my common iliac? That way you've named the common iliac. So can small mice really get in my common iliac? So the can stands for celiac. Small mice, superior mesenteric. Really is renal. Get is gonadal. In my is inferior mesenteric. And then common iliac is common iliac. little bit later, I'll show you where these are at. This is just showing you on the fetus. Don't overthink this too much, but this is the placenta. This is, where the baby is getting oxygen and nutrients. See this big red guy? That's a vein. Notice where it says umbilical vein, because it's carrying blood to the heart. Notice the way it's red, because it's full of oxygen, because it just got oxygenated in the placenta. Look at the umbilical arteries. They're blue. That's because they're going away from the heart. They're going to the placenta to get oxygen. Okay. Oh, and there's your little foramen ovale. We talked about that. That's the little hole in between your right and your left atrium when you're a fetus. And that allows, see this nice oxygenated blood coming up? Some of it can just shoot straight across to the left side of the heart because it's already oxygenated. And then it goes out to the body, right? There's also a little ductus arteriosus. This is an adult heart. It's closed, so it's called the ligamentum arteriosum in an adult. But in a fetus, that's another little bypass for the lungs. So say you got oxygenated blood that came in here from the placenta, and it's trying to go to the lungs, which is where you would ordinarily go to get oxygenated. Some does go to the lung because they're growing, but some of it just shoots straight up into the aorta. This is in a fetus, right? And then that oxygenated blood just gets distributed to the body from there. So the foramen ovale and the ductus arteriosus right here and here, that's just ways of bypassing the lungs because you've already got oxygen in your blood. Yeah, does some of that blood go to the lungs? Yeah. So all three of these things are happening at the same time. Some of that blood's shooting across to the left atrium. A lot of that blood's going into the right ventricle like it's supposed to, and then some of it goes to aorta, some of it goes to the lungs. That's just fetal circulation. Then when you're born, after your first few breaths, this should close up. The foramen ovale closes up. It's called the fossa ovalis when it does. And the ductus arteriosus closes up, and that's called the ligamentum arteriosum after it's, gone away. So can they stay open when a baby is born? Yeah, and that causes problems because you're mixing oxygenated with deoxygenated blood. And that's just basically what we were saying. I don't like the way that's drawn though. Yay. Okay, so let's look at, there's your 3 layers. We did those. Don't miss the easy stuff. Superior vena cava. Don't forget, you have brachiocephalic veins. You have 2 of them, but you only have 1 brachiocephalic artery or trunk. Okay, so this would be an internal carotid. That would be a subclavian vein, and they're flowing together into a brachiocephalic vein, and then into the superior vena cava, and into the heart. Same thing over here. Okay, where off the arch of the aorta, the blood's going away. It's going out that brachiocephalic trunk, or it's going up that left common carotid, or up and out of this left subclavian. Okay, so don't miss the easy point name stuff. And a lot of things are just named after bones or regions, right? So you're going to have axillary artery, brachial artery, then you're going to have radial and ulnar. And I got a better picture of that somewhere. There's everything we've named. I don't like the way they drew the fossa ovalis. It should be way over here. It's in between the 2 atria. Oh, there's your little opening of your coronary sinus. Remember that little expanded vein on the back of your heart? It empties into the right atrium too. Yeah, just don't miss the easy stuff like interventricular septum, papillary muscles, chordae tendineae, left AV valve, right AV valve, pulmonary valve. You can't see it, but there's an aortic valve behind there. Oh, there's a nice ligamentum arteriosum. And there's our boom, 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 our big 3 vessels coming off of our aorta, brachiocephalic trunk, left common carotid, left subclavian. And notice the way they drew your pulmonary trunk and arteries in kind of a purple. They're trying to show you that it's an artery, but it's carrying deoxygenated blood. And look at the way they drew the veins, the pulmonary veins. You can't see the ones coming from the other lung, but they would be red too. They're red because they're full of oxygen. Don't miss this. That's the carotid sinus. Put a box around that. Don't call it the coronary sinus. That's totally different. That's the blue one on the back of your heart, remember? This carotid sinus has pressure receptors in it. That's at the base of your internal carotid, and it goes up here to the circle of Willis, they call it. And Cuyamaca, we're going to make you learn the circle of Willis, and I'll just touch on it for Southwestern. But it's a circle, and and the blood flows into this circle, and it can go around it to different areas of the brain. So when you're taking somebody's pulse, say they have cast on their wrist and you can't take their pulse, and you decide you're going to take it on their neck, be careful. Don't squeeze both sides of their neck. They might pass out because there's pressure receptors in here. And even if you're just doing it on one side like you're supposed to, just make sure they're sitting down and kind of lean back, because that can cause basically like a reaction. And all this pressure receptors in here all they know is that dang, my pressure went way up. I hope I don't blow out a vessel. And so you're going to get this compensatory vasodilation, and that can make them pass out. So be careful when you're taking somebody's pulse right here. Probably you need to do it a little further down and just do it on one side. There's the vertebral artery, and that's going up to the circle of Willis too. They didn't draw it that well, but see that little circle. Okay. That's just showing you some vessels. This is kind of nice because here you can see subclavian becomes an axillary, axillary becomes a brachial, brachial splits into radial and ulnar. That's all fair game to point out. If you're descending aorta, if it's up here, it's called the thoracic, descending thoracic. And here's your abdominal aorta down here. Here you can see your celiac trunk. See the three little branches? One's going to the liver, that would be hepatic. One's going to stomach, that would be gastric. And one's going to the spleen, that would be splenic. I would never point which one's what. Just know that those three organs are fed. Then there's my superior mesenteric, but it's cut off. You can't see where it's going. There's my two renals. There's a gonadal. And then there's my common iliac. So I think I got a better up close. Yeah. So here you can see going to the liver, going to the stomach, and going to the spleen, right? So gastric, hepatic, splenic. Then there's my superior mesenteric going to the upper parts of the digestive system. There's my inferior mesenteric going to the lower parts. So that's a pretty good picture. Be careful here, you guys going to med school and PA school. On the cadavers, see the way this is. So there's my internal iliac and my external iliac. If they put the pen right here, right above this inguinal ligament, that's external iliac. If they put it right below it, it's now called the femoral. So be careful with that. That's kind of like a dividing line. Same darn vessel, just gets different names when you go past that. They love to do that. Okay, that's the cat. Then, so see the femoral coming down here? It kind of goes behind the knee, and now it's called the popliteal, and then it's going to split into the anterior and posterior tibule. On the veins, make darn sure you know this median cubital, because that's a lot of times you draw blood there. I kind of like the way this is drawn, so that's going to be the brachial. And this is going to be the basilic. Got its own name. And this one's got its own name, cephalic. And why they call that cephalic in the arm, I do not know. But anyway, that's what they call it. So here's brachial, There's basilic and there's cephalic. Make sure you know median cubital. Sorry, cubital. I hope that's what I said last time. Median cubital. Okay, because you're going to be drawing blood from there. Did all that. And then this is showing you your internal jugular and your external jugular and your vertebral vein. So remember, all this is bringing blood to the heart, to the heart, to the heart, right? Don't confuse it with arteries, which are bringing blood away from the heart. And then see how this is flowing into your subclavian, then your right brachiocephalic, then your superior vena cava, and then boop, into the heart. So it's kind of nice. There's that median cubital. You can see it really nice. You can see the brachial really nice. You can see the basilic really nice. And the cephalic. Got renal veins also. Little anomaly here. I could just do it as a bonus. Your gonadals, look at your gonadal vein here. It's flowing into your inferior vena cava on the right side. And on the left side, it doesn't do that. It goes up to your renal vein. And then the blood goes across from the renal to the inferior vena cava and up. It's just a consideration in surgery. You got to be careful with that. Say if somebody's getting a kidney removed, you got to be careful because this gonadal is flowing into that renal vein. Okay. That's just showing you the mesenteric stuff. And then there's your femoral vein, right? And be careful with this guy here. This is the great saphenous. Put a box around that. That's an important thing. You can probably see it on yourself. It goes down the outside of your leg. I mean, the inside, but it's towards the surface, I guess I should say. Remember that saphenous nerve? It's kind of right next to that. So I think they actually take either this or branches off of it to do those bypass surgeries, or they used to. I'm not sure they still use that. All right. So I think that's it. Okay, so I'm going to stop there, and then we'll put this up on the website. Okay, end the meeting, and end meeting for all.